This video for the Vital Syllabus considers different possible routes for the creation of superintelligence, namely intelligence that is significantly more powerful and more general than the intelligence of today's humans. Before discussing superintelligence, let's start with the simpler notion of intelligence. Intelligence can be analyzed as the ability to observe what is happening in the environment, understand what is happening in the environment, make predictions about what will happen next, consider the likely results of interventions upon the environment, plan and conduct experiments to gain more information, and make progress towards goals as a result of all of the above. To be clear, there are many different kinds of intelligence applicable in different kinds of environment. For example, chess intelligence applies when the environment consists of games of chess. Social intelligence applies when the environment consists of other people in social interactions. Musical intelligence applies when the environment consists of musical pitch, timbre, rhythms, melodies, and harmonies. Spatial intelligence applies when navigating unfamiliar landscapes, and so on. It's common for someone who is gifted in one kind of intelligence to be less capable in another kind. Likewise, various animals demonstrate various types of intelligence, but fare less well in others. Some dogs have great intelligence in discerning specific odors in an environment full of different smells, and can therefore raise alerts about suitcases that contain illegal substances. But these dogs are unable to read and write. Some birds have great intelligence in navigating great distances between particular geographical locations, but lack intelligence in, for example, performing medical procedures on one another to repair broken bones. In other words, human intelligence lags behind that of various animals in some aspects, while exceeding it in others. However, there's a sense in which humans have a general intelligence that allows us to reshape the physical environment in line with human goals, despite the sometimes contrary intentions of the other species with whom we share the biosphere. Thus, the future fate of gorillas, or dogs, or geese as species depends on decisions and actions of humans, and not the other way around. Numerous other species, in which animals used to number in millions, have already gone extinct due to the actions of humans in the past. The question about superintelligence is whether a new type of organism might arise, which outperforms humans in general intelligence, in broadly the same way as humans outperform gorillas, dogs, and geese. If so, then the future fate of humans will depend on the decisions and actions of these new super-intelligent beings. One writer who pioneered the discussion about different routes to the emergence of superintelligence was Vernor Vinge of the Department of Mathematical Sciences at San Diego State University. Vinge is also well known as an author of science fiction, having received 5 Hugo Awards for his novels and novellas. Vinge published an essay in 1993 entitled, "What is the Singularity?" The article starts with the declaration, "Within 30 years, we will have the technological means to create superhuman intelligence. Shortly after, the human era will be ended. Vinci also wrote that any superintelligence would not be humankind's tools any more than humans are the tools of rabbits or robins or chimpanzees. The subject of the timescale for the arrival of superintelligence will be considered in another video in this Vital Syllabus series. For now, the subject is the set of different ways in which superintelligence might arise. Vinci's article analysed 4 such ways. First, individually powerful superintelligent computers. Second, networks of relatively simple computers in which a distributed superintelligence emerges from the interaction of these computers. Third, humans becoming superintelligent as a result of highly efficient human-computer interfaces. And fourth, human brains or other biological systems being significantly improved as a result of biotechnological innovation. Before looking more closely into the mechanisms listed by Werner Vinci for the creation of superintelligence, one more route should be mentioned too. Groups of humans, aided by information systems, form into collections that manifest a superintelligence. Indeed, this route has already been significant throughout human history. Communities can be much wiser than individual members. Consider the scientific community, or any large network in which there's effective communication and tolerance of different opinions. A particular case of a community with greater intelligence than individual humans is the business corporation. When it functions smoothly, the corporation organizes many employees along with data systems so that the different skills and abilities of these employees complement and support each other. This example of corporations raises an important point. A corporation as a whole can have goals that diverge from the individual life goals of the employees who form the corporation. The corporation can put a particularly high value on maximizing financial profits, even if the managers and employees have a wider range of individual motivations. It might be said that corporations are already an example of superintelligences that are approaching a state of uncontrollability. If corporations are already approaching uncontrollability, how will matters change when any of the 4 mechanisms mentioned by Werner Vinci succeed in raising intelligence to a yet higher level? Each of the 4 routes mentioned above involve improvements in hardware. Individual computers can have faster processors, greater storage capacity, and greater processing efficiency. Networks of computers can become larger, with more connections between the individual items, and can collect more data because of increased ubiquity of the sensors built into Internet of Things devices. Hardware can become able to detect a wider range of brain signals, allowing faster and richer two-way communication between humans and computers. And brain cells can be made more resilient and efficient as a result of biotechnological interventions. In each case, it is conceivable that superintelligence will result merely as a result of these hardware improvements. However, it is more likely that improvements in software will be needed too. Again, there are improvements in each of the 4 routes. Software in individual computers may match more closely aspects of the operation of the human mind. Software in networks could allow individual components to broadcast precise information about their specific capabilities and to form subnetworks optimized to particular tasks. Software in brain-computer interfaces could more reliably separate the signal from the noise of neural processing and therefore target interventions more precisely. And software in augmented brains could form subnetworks of brain cells in ways that outperform present-day brain architectures. Again, it's possible in each case that an apparently simple step of forward progress could unexpectedly yield a wide range of performance improvements on account of logical connections between the underlying mechanisms that weren't previously understood. That's a reason to make preparations for superintelligence arriving sooner than the median, most common estimate. One more feature that the four routes have in common is the potential for an acceleration in the rate of progress due to self-reinforcing positive feedback cycles. The output of one generation of progress can assist improvements in subsequent generations. Generation A, Generation B, C, D, and so on. Thus, more powerful computers can help design and manufacture even more powerful computers in the next generation. More powerful networks can help design and manufacture even more powerful networks. People with improved brain-computer interfaces can think more clearly and more creatively and can help design and manufacture even better brain-computer interfaces. And if brains become enhanced due to biotechnological interventions, they will, again, enable thinking that is clearer and more creative, and hence the design and manufacturing of new biotechnological systems to enhance brains even further. We should also anticipate crossover positive feedback cycles in which improvements in any one of these four areas can also lead to improvements in the next generation of any of the other areas. In other words, there can be more complicated positive feedback cycles resulting in even faster acceleration. That's another reason to make preparations for superintelligence arriving sooner than the median estimate. This brings us to a number of key questions arising. A. Which of these four routes is the most likely to reach superintelligence first, given a sufficient amount of funding and support? B. Are there qualitative differences in the types of superintelligence that are likely to result from these four routes? For example, are some types more likely to treat humans with benevolence, or will they be easier to control? And C. How will each of these four routes interplay with the latent superintelligence that is already present in hard-to-control business corporations? Due to the significant uncertainties about superintelligence, any answers to these questions are inevitably tentative. However, here are some points to consider. For question A, there appear to be more bottlenecks and constraints in the human brain and skull than in silicon computers and distributed networks. It's readily conceivable that the latter could scale up by factors of 1,000 or more, whereas options for scaling up the former are more limited. That suggests that routes 1 or 2, the ones without biological bottlenecks, are likely to result in quicker progress towards superintelligence and indeed in the most powerful versions of superintelligence. Humans whose thinking is improved by routes 3 and 4 will still be more intelligent than present-day humans, but that improved intelligence will nevertheless lag behind, potentially a huge way behind, the AIs created by the non-biological routes. For question B, it is sometimes suggested that a superintelligence with a human at its core will be more likely to act in ways that are beneficial to humanity. However, there is some evidence against that hopeful viewpoint. After all, some of the most dangerous people on the planet are also among the most intelligent on the planet. Moreover, a person who thinks they are acting in ways that will benefit humanity may make a mistake, even if they are hyper-intelligent, in the same way that a hyper-intelligent AI could make a mistake. That suggests that questions of values and control need to be solved for all 4 routes, rather than just the first 2. Finally, for question C, we should recognize that business corporations are one more factor that can take part in crossover positive feedback cycles with other types of superintelligence. Business corporations can become successful by taking skillful advantage of one generation of artificial intelligence. These corporations can, as a result, gain more power and wealth. This allows them to invest more heavily in projects to improve artificial intelligence further. And as a result of that, they can gain even more power and wealth, leaving their previous competitors far behind. The near uncontrollability of powerful business corporations will therefore interact with the near uncontrollability of superintelligent AI. Thank you for your attention to this Vital Syllabus presentation on different routes to superintelligence. The Vital Syllabus contains more material about superintelligence and the singularity. For example, for measures that will increase the likelihood of a positive singularity, see the video on the singularity principles. For discussion of humans potentially controlling superintelligence, despite it being significantly more capable than us, see the video, The Control Problem.